Hello friends, here we have to evaluate the double integral by changing the order of integration. Here we can see the given double integral is 0 to infinity here, and this is the limit 0 to y e to the power minus y square upon x dx dy. So you can see here in the right hand side this limit is function of y. If right hand side this limit is function of y, so this is the limit of x. So we can also write this x equal to 0 to x equal to y here. In the left hand side, in the right hand side, if this is the limit of x, so in the left hand side this is the limit of y here. You can see in the right hand side, if the limit is function of y, so this is the limit of x. So x going from 0 to y. If on the right hand side this limit is of the variable x, so in the left hand limit this is the limit of y. So here integration is bounded by x equal to 0 to x equal to y and y is equal to 0 to y is equal to infinity. Now we draw the given region. So first we draw here the vertical line, this is y axis, and this horizontal line, this is x axis here. This is y axis and this is x axis here, and this is the origin here. Now we can see here x equal to 0. This is the equation of y axis, and y is equal to 0. This is the equation of x axis. X equal to y. This is the line which is passing through the origin, makes angle pi by 4 with the positive direction of x axis. This angle is pi by 4 here, because this is the line x equal to y here. Now y is equal to infinity. Y is equal to infinity is the line which is parallel to x axis and is at distance infinity from x axis. We suppose that this is the line, y is equal to infinity, which is parallel to x axis, and suppose that this distance is infinite here. Suppose that this distance is infinite. Y is equal to infinity is the line which is parallel to x axis and it is at a distance infinity from x axis. Now we can see here this is the point of intersection of y is equal to infinity and x equal to y. So this point of intersection, suppose this is a point and this is infinity comma infinity, because if we put here y is equal to infinity, we get x equal to infinity, so the point of intersection is infinity comma infinity. So the a point lies on infinity comma infinity, and this b point, suppose this is y axis, and on the y axis x coordinate is 0 and this distance is infinity, so b point is, suppose b point coordinate is 0 comma infinity, and this is the origin, so coordinate of origin be 0 comma 0. Now we can see here the given region is, this is y x equal to 0, x equal to 0 is y axis, y is equal to 0, this is x axis, x equal to y is the line which is passing through the origin and makes angle pi by 4 with the positive direction of x axis, and y is equal to infinity, this is the line which is parallel to x axis at infinite distance. Now here we have to change the order of this integral. and we see here on the right side this limit is function of y. So when we change the order of the double integral, we take the strip parallel to y axis. So we take here, suppose this is the strip PQ parallel to y axis. Now the given region is here. Given region is here. This is the given region. This is the given region here. We can see, and this P point lies on infinity here, and this A point also lies on infinity, and this B point also lies on infinity. Now when we change the order of this double integral, we can see here now the limit on the right integral becomes limit of y, and in the left integral becomes the limit of x. So we can see here when this PQ strip goes from OB to A point, it's covered the distance. This is the point, suppose this is the point here, infinity, this distance is infinity comma 0. So this PQ strip goes from B point to A point, it's covered the distance along x-axis from 0 to infinity. So this distance is 0 to infinity here, and in the PQ strip we can see that lower end Q lies on the line x equal to y. So the lower limit of y we find from this line x equal to y. So y is equal to x here, and the upper end of this PQ strip is P, which lies on the line y is equal to infinity. So here the upper limit of y is infinity here, and this y e to the power minus y square upon x, and this dx dy can be written as dy dx. Now on changing the order of the double integral, the double integral can be written as 0 to infinity, here x to infinity, and y e to the power minus y square upon x dy dx. Now this double integral evaluate. Now we can see here the double integral is 0 to infinity, x to infinity, and y e to the power minus y square upon x dy dx. Here we can see that on the right integral this is limit, this limit is function of x, so this is the limit of y. So first we integrate with respect to y. So with respect to y, integrate first 0 to infinity, x to infinity, y e to the power minus y square upon x dy and dx. When we integrate this, we put here t is equal to minus y square upon x. When we differentiate this, so this can be written as x t is equal to minus y square. When we differentiate this, so x dt is equal to minus 2y dy. So we can see here x upon minus 2 dt is equal to y dy. So in place of y dy we put here minus x upon 2 dt. So this can be written as minus x upon 2 dt, and in place of minus y square upon x this becomes t, and this limit is x to infinity here, and this is dx. Now integration of e to the power t with respect to t, this is also e to the power t here. Now we put here upper limit minus lower limit in place of t, we get Here put value of t, that is minus y square upon x. Now we put upper limit in place of y, that is infinity. So infinity square is infinity divided by x, that is infinity. So this is minus infinity. And in place of y we put here x. So this is e to the power minus x. Now we can see here this e to the power minus t is 0 and e to the power minus x dx. Now this minus multiplied by minus we get plus here, and 1 by 2 is constant, so it is outside the integral sign, x e to the power minus x. Now we integrate this by integration by parts. So first we write here x, integration of e to the power minus x is minus times e to the power minus x, minus integration differentiation of x is 1 here, and integration of e to the power minus x is minus e to the power minus x here, and the limit is 0 to infinity. Now we know that the limit of x into e to the power minus x, x into e to the power minus x, here this limit is 0 here and 0 minus 0. When we take limit of x e to the power minus x at x tends to infinity, we get 0 here, and when we replace x equal to 0 here, so e power 0, that is 1 into 0 0, and this minus minus plus here, but integration of e to the power minus x is minus e to the power minus x, so this becomes minus e to the power minus x, and we write here. Now this term is 0 here. Now we can see here minus applying upper limit minus lower limit. So e to the power minus 50 is 0 here, and e to the power 0 is 1 here. So this minus minus plus, so this gives 1 by 2 here. So the limit is 1 by 2 here. You can see here, if we evaluate limit x tends to infinity of x e to the power minus x, so this can be written as limit x tends to infinity x upon e to the power x. Here we can see this is the form of infinity by infinity. So applying L'Hopital rule, we get here differentiation of x is 1 here, differentiation of e to the power x is e to the power x. When we substitute here limit, so e to the power infinity, and this is 0. So in place of x e to the power minus x, when we take limit x tends to infinity, we get 0. So the answer of this double integral is 1 by 2. Thank you.